Hello, and welcome to the Daily Space. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain. Today is a day with a lot of rocky and planet shaped news, and it all starts with the possible discovery of a planet orbiting around the bright star Vega. Depending on where you are in your time zone, Vega is currently rising around midnight for observers everywhere except in the extreme north. Vega is the brightest star in the constellation Lyra, and with a distance of only 25 light years, it has been a favorite for science fiction authors imagining novel destinations. From being the capital of the Vega province in the Foundation series, to being the home of the transmitter in Contact, and the home system of the wise old yogurt in Spaceballs. Well, Vega comes up a lot. And now it seems that maybe, just maybe, Vega actually has at least one planet. According to UC Boulder student Spencer Hurt, who did this work as part of a summer program at Harvard, it would be at least the size of Neptune, potentially as big as Jupiter, and would be closer to Vega than Mercury is to the Sun. This planet, if it is there, is on a tiny orbit going around its star every 2.5 days. And it would be the second hottest planet so far discovered. Hurt goes on to explain that close to Vega, the candidate world might puff up like a balloon, and even iron would melt into gas in its atmosphere. Because Vega is about twice the mass of the Sun and rotates much faster, detecting planets around it is much harder, and more work will be needed to confirm this result. But where there is one planet, there could be more. And it's awesome to think we may be finding the places only dreamed of in science fiction. This work is published in the Astronomical Journal.
As you've heard us say more than once, no one really understands the details of planet formation yet. And anyone who tells you they know exactly how planets form is either lying or on their way to a Nobel Prize. Part of the confusion comes from trying to separate what happens when the planets initially form and what happens later when those young planets get clobbered by countless asteroids and comets. We're pretty sure that the early solar system had a gradient of materials with different stuff being located in the inner and outer solar system. This matches what we see in the composition of asteroids from different locations and what we seem to see with planets and moons. The details aren't clear, however, and every time a comet or asteroid comes close enough, we try to measure its composition if we can, and then question, did Earth's water, nitrogen, whatever, form with the planet or come from collisions or both? Back in 2016, Comet 2013 Catalina passed near enough to Earth for the Sophia Airborne Observatory to look for specific elements in its tail and coma. In a new paper in the Planetary Science Journal with lead author Charles Woodward, researchers discuss observations of carbon, the base element of life, in the comet. According to Woodward, we're still not sure if Earth could have trapped enough carbon on its own during its formation, so carbon rich comets could have been an important source delivering this essential element that led to life as we know it. This particular comet originated in the Oort cloud, far out beyond the observed planets, where more carbon may have been located. More observations of more comets are needed, but this is an interesting start. More and more, it seems that our world required the heavy bombardment of comets and asteroids to make it eventually habitable to life.
And we wouldn't just be taking more observations of comets and asteroids. We're also going to continue to look at the compositions of other worlds. Part of that work will be done by the newly arrived Perseverance rover, Percy, which is still undergoing its initial checkout after landing. Oh, and that landing site? It has a new name. Percy is located in the Jezero crater on a patch of red that is now called Octavia E. Butler Landing. As part of its rover checkout, Percy took its first drive and went about 6.5 meters or 21.3 feet. This wasn't exactly a record setting drive, but it was enough to make sure things are working. Once Percy has dropped the Ingenuity helicopter and begins its regular science operations, it's expected to travel 200 meters or so at a time. According to Anis Zarafan, a testbed engineer at NASA JPL, when it comes to wheeled vehicles on other planets, there are few first time events that measure up in significance to that of the first drive. This was our first chance to kick the tires and take Perseverance out for a spin. The rover's six-wheel drive responded superbly. We are now we are now confident our drive system is good to go, capable of taking us wherever the science leads us over the next 2 years. In addition to doing a bit of driving, the mission team is also installing software updates, checking out cameras, and stretching out the robotic arm and testing all its joints. Honestly, if you packed me in a tiny capsule and sent me on a cold 6-month journey to another planet, I'd probably be moving slowly and stretching carefully myself. So far, everything looks good, and we can't wait to see the little rover doing science.
Before the break, we have one more story. Aurora photographers are once again responsible for finding and defining a new feature in our Earth's aurora. Also called the northern lights, these generally green and red colored features in the sky are created when our atmosphere interacts with particles from the sun that are racing along the Earth's atmosphere. Observed patterns often include curtains and pillars, and now we know they can also include dunes. This pattern was noted in 2015 by the Ursa Astronomical Association in Finland, but documented again for 3 years. By looking at photos taken from multiple locations, this band of amateur astronomers was able to determine the dunes were located about 100 kilometers up in the atmosphere, where other aurora features also occur. Working with local atmospheric scientists, the team was able to figure out these features are associated with variations in the density of oxygen atoms in the upper atmosphere. Under just the right and pretty rare conditions, temperature inversions and wind shear in the atmosphere can cause waves on higher and lower density that crop up over great distances. This work is published in AGU Advances and highlights that anyone can make a discovery, and the true definition of a scientist isn't how many degrees you have, but rather how often you say, "What is this?" and work to share what you find with others. After the break, we'll be back to discuss the future collision of our galaxy and the nearby Andromeda galaxy. So don't go away.
Let's face it, humanity's time is limited. We either need to figure out how to get off this world and survive on other planets, in other solar systems, or humanity is goners. Exactly how long we have depends on what you're looking at. With the worst case climate change models, we have a few hundred years. But if we can get ourselves together, we should be able to avoid that. But what we can't avoid is the inevitable end of our sun. In roughly 5 billion years, that friendly globe in the sky is going to expand out, eat at least Mercury, probably also Venus, and maybe us. And even Mars is going to be a bit charbroiled by the end of it. Well, it's bad enough that our sun is going to blow up and destroy things. In 5 billion years, that might not be the most insane thing going on. At the same time, our sun is evolving to its next phase. Our galaxy is going to be merging with its nearest large neighbor, the Andromeda galaxy. Getting a precise measure of the size of our galaxy from inside our galaxy is a bit tricky, but we think that Andromeda is the bigger of the two systems, and as we all gravitationally tangle, both systems will lose their amazing spiral structure. And in the tangle of wild things that will happen, gas and dust in both systems will collapse to form stars, while more of that gas and dust falls into the system's supermassive black holes, and that remaining gas and dust is going to get strung out into trails of debris called tidal tails. This will make for an amazing sky, with potentially twin jets coming out of the cores of both systems. and amazing nebulae in all directions. We understand galaxy collisions from looking at other galaxies in various stages of merging together and running simulations to see how we can recreate what exactly is going on. This is like looking at all your grandmothers and realizing you're destined to have gray hair and cataracts. Some things just come with your genes. Galaxies don't exactly have genes, but the building blocks of their structure dictate the future of their evolution in just the same way. According to models, the resulting Milky-Andromeda galaxy will be an elliptical galaxy. And while it will start with two supermassive black holes, newly published results show that roughly 17 million years after the merger is complete, which will be about 10 billion years from now, these supermassive black holes will merge and in the process release, in the form of gravitational waves, 10 quintillion suns of power. That is a billion billions worth of solar power. Any civilization with a system like our Earth's LIGO system that is within our local group of galaxies should be able to detect this future event. Space is big. It's also mostly empty, and the amount of time it takes things to travel can be mind boggling. Andromeda is headed toward us at a breakneck 116 kilometers per second. At this rate, Andromeda could travel from New York to London in 48 seconds. Nevertheless, it will be order of 5 billion years before the slow motion impact begins. And unfortunately, none of us will be here to witness it. After the break, we will be back to talk about a near miss that we are actually really glad we and our planet aren't going to witness in our lifetime. Stay tuned.
Speaking of collisions, back in 2004, an asteroid was discovered and named 2004 MN4. It's over 300 meters across, and at the time of the discovery, the calculated orbit caused much concern as it seemed to bring the asteroid on a potential impact trajectory with Earth in 2029. Headlines, of course, went wild with sensational news, referring to 2004 MN4 as a killer asteroid and generally scaring the bejesus out of the population. The team that discovered 2004 MN4 was composed of Roy Tucker, David Tholen, and Fabrizio Bernardi, and they used the Kitt Peak Observatory in their search. They are also responsible for naming this small body Apophis. Now, I could get into the mythology about that name, but let's face it, the show Stargate SG-1 was still popular at the time, and a couple of the discoverers were fans. Since Apophis was the big bad for a couple seasons and he was always bent on the conquering and destruction of Earth's human population, naming this potential impactor after him sounded like a good idea. So, just how big was the possibility of a collision with Earth in 2029 at the time of the discovery? Less than 3%. And that chance went down to zero once scientists started going through older images and refining Apophis's orbit. Honestly, it's hard to believe that we're closer to that potential impact. Remember, it's not actually going to hit Earth than we are to the discovery. Of course, as we saw last year, media coverage ignores asteroids when they're no longer a threat, which means the scary stories stay in the public's collective consciousness. I still get asked about Apophis routinely. But there is a secondary issue with Apophis in that it had a chance of passing through a gravitational keyhole that could change the orbital trajectory enough to become a threat in a 2036 pass. That too is no longer predicted to happen based on even further refined orbital calculations. The next potential threat is 2068. So, why is Apophis in the headlines again? Headlines that are, once again, being a bit ridiculous. Demon asteroid, god of chaos asteroid, most intimidating asteroid, Jumbo. Well, Apophis had a closest pass of Earth last week, coming within 15 million kilometers, and more importantly, giving astronomers an opportunity to observe the asteroid and make even more refined calculations. Starting on March 3rd and continuing through March 14th, The Green Bank telescope has teamed up with NASA's Goldstone to collect even more observations of Apophis. Planetary defense is a hot topic in the space world these days, and as Green Bank's recent press release states, predicting if there is a real chance of impact decades ahead of time gives scientists the opportunity to take action to manipulate the orbit of Apophis to avoid a collision in the future. You see, that 2029 pass is still going to be, as a colleague said, spicy, since Apophis will pass between the orbits of the Earth and Moon at about 32,000 kilometers and actually be at the same distance as some spacecraft in their orbits. So it's important to understand as much as possible about Apophis's orbit, and Green Bank's observations are crucial. The telescope is using a bistatic radar, bouncing signals off the asteroid from Goldstone that are then collected by Green Bank's dish. And since it's all done in radio wavelengths, no one has to wait for nightfall. Near Earth asteroids like Apophis, that are considered to have some level of potential impact threat, are why missions like the upcoming Double Asteroid Redirection Test, or DART, are of vital importance. While the current threat calculations for Apophis are close to zero, they are not zero. And there are a lot of asteroids out there. Being able to deflect an asteroid even slightly could be the technology needed to save life on Earth from another Chicxulub event. Nonetheless, headlines can be misleading, and the bottom line is that Apophis is not a threat to life as we know it, not now, and not in 2029. But we'll keep updating you as NASA and other teams get more data. We'll be back in a moment to talk about the ease with which we are now finding exoplanets and the difficulty we have in finding certain types. Stay tuned.
Exoplanets. Exoplanets are everywhere. Since the 1990s, we have discovered over 4,000 exoplanets, hot Jupiters, big puffy gas giants orbiting close to their parent stars, mini Neptunes, super Earths, and everything in between, or so it seems. We're only just starting to dig into the compositions of atmospheres of these worlds, but there have been exoplanets where diamonds likely rain down, where magma flows from one half to the other, tidally locked worlds around white dwarfs, destroyed exoplanets, all of it. None of these sound particularly habitable for life like us, though. And that's the big question, problem. Where are the worlds with liquid water where we, or life as we know it, could exist? To answer this question, scientists have focused on figuring out how the Earth came by its store of water. One of the prevailing hypotheses is that water arrived by chance through the strike of large asteroids that brought ice with them. We mentioned that earlier in the show. Now, a team at the University of Copenhagen has put forth a different hypothesis. And in a new study published by Science Advances, they calculate that water was present during planetary formation. According to lead author Anders Johnson, all our data suggest that water was part of Earth's building blocks right from the beginning. And because the water molecule is frequently occurring, there is reasonable probability that it applies to all planets in the Milky Way. The decisive point for whether liquid water is present is the distance of the planet from the star. Basically, Earth collected the first 1% of its current mass by capturing millimeter sized dust particles that contained ice and carbon. These ingredients are common around young stars, so it makes sense that they were present around our sun too. Then the planet's growth sped up, collecting more and more material. After about 5 million years, Earth had its current size, and Anders further explains the temperature on the surface rose sharply, causing the ice in the pebbles to evaporate on the way down to the surface, so that today only 0.1% of the planet is made of water, even though 70% of the Earth's surface is covered in water. This new theory increases the probability that there is plenty of worlds out there that have liquid water because they all came out of essentially the same material, and that material included water ice from the start. No matter the chance of acquisition. And as co author Martin Bizzarro notes, With our model, all planets get the same amount of water, and this suggests that other planets may have not just the same amount of water and oceans, but also the same amount of continents as here on Earth. It provides good opportunities for the emergence of life. Now, all we have to do is find those planets somehow, but at least we know they're likely out there to find. This has been the Daily Space. Join us again tomorrow for our weekly Rocket Roundup show with host Annie Wilson.
You can find more information on all our stories at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
And if you want to learn more from people like us, Nick Castle is teaching a 6-week class on what it takes to build yourself a home on Mars. So go check it out at cosmoquest.org and sign up to learn from, well, one of the mission ops folks for Mars rovers. Thanks.